Alright, welcome again in another tutorial of the topic differentiations. So, tunaendelea na points of inflection. Tuone mfano. It says, find the turning points and the point of inflection on the curve. Y is equal to x power 5 minus 5x power 4 plus 5x power 3 minus 1. Kwa hiyo kwanza nitatafuta derivative dy dx. Then nikifanya dy dx sasa na 0, nikatafuta values za x hapo, nitapata hizo turning points. Okay, then hizo turning points sasa nitataka nidetermine kama ni maximum, minimum au point of inflection. Kwa hiyo zipo method mbili sasa kufanya hivyo. Ya kwanza ni kuangalia change in sign as the graph passes through the turning points, change in sign of dy dx, okay? Ya pili ni kutumia second derivative. So nitatumia second derivative kwenye hii example, okay? So for example hapa nikitafuta dy dx, I'll just get 5x power 4 minus 20x power 3 plus 15x squared, okay? So in the derivative of polynomials ndivyo inavyofanywa hivyo. Okay, sasa dy dx I'm gonna say is equal to 0, okay? This means that my 5x power 4 minus 20x power 3 plus 15x squared is equal to 0. Look, 5, 5, 5, okay? X squared, x squared, x squared. Let me factor out 5x squared, okay? So I remain ndani na x squared hapa minus 4x plus 3. So nitakuja kupata kwamba 5x squared hapa nitapata x squared minus 4x minus plus 3, okay, is equal to 0. So hii quadratic equation na yenyewe naweza nikaifactorize. So it's going to be 5x squared. It's going to be x minus 1 x minus 3. So x minus 1 x minus 3. So nikichukua x minus 1 times x minus 3 napata hii quadratic equation. So from here now I see that the values of x is 0 or 1 or 3. So these now are the turning points. So in order to see if these turning points are maximum, minimum, or points of inflection, I need to find the second derivative. Now remember the first derivative tulipata ilikuwa ni 5x power 4 minus 20x power 3 plus 15x squared, okay? So nikiderive hiyo, maana nitapata second derivative, okay? Maana itakuwa ni 20x power 3 minus 60x squared plus 30x, okay? So this is my second derivative ambayo nimeipata. Okay, so is 20x power 4 x power 3 minus 60x squared plus 30x, okay? So turning point zangu zilikuwa x equals to 0, x equals to 1 na x equals to 3, okay? Kwa hiyo nasipachika hapa, okay? Value naopata itanisaidia sasa kujua je hiyo ni turning point, ni minimum point au point of inflection au ni maximum point. So nikiingiza 3 kwa mfano kwenye ile pale second derivative pale juu, 3 cube ni 27 mara 20 ni 540. 3 square ni 9 mara 60 ni 540. 540 to 540 ni 0. 3 mara 3 ni 90. So hapa nitapata positive 90, okay? So this is positive. Kwa hiyo x equals to 3 bila shaka ni minimum point, because when the second derivative is positive, then the turning point is minimum. Nikiweka 1 je, when I put 1 in my second derivative now, 1 cube ni 1 times 20 ni 20. 1 square ni 1 times 60 ni 60. 20 minus 60 negative 40. Negative 40 plus 30 is negative 10. Hapa napata negative now. So when the second derivative is negative, it means x equals to 1 is a maximum point, okay? Maximum point. So mbaki 0, nikipachika 0, what's my second derivative? Is 0. Okay? So ikiwa 0, it means it's neither maximum because it's not negative, and it's not neither minimum because it's not positive. So what is it? So x is equal to 0 is my point of inflection. So that's how you determine these points of inflection. Sasa unaweza ukaziandika in terms of x, y. If you want to find the y values ya hizi point maximum, minimum and the point of inflection, rudi tu kwenye ile example, ile y is equal to ile equation of a curve, okay? Then pachika is values of x, you get the y value at the maximum point, the y value at the minimum point, and the y value at the point of inflection. So ukitaka kuziandika in terms of x, y. Let me say now that's all about point of inflections. See you again in the next tutorial where we'll continue with application of differentiations.